So chapter 5 is how to code control structures. Control structures are if-else statements, loops, that kind of stuff, switch statements, and that way you can kind of control where your code's going to go and what you want done. The objectives, part 1, applied, given a Boolean expression and the values for the variables in the expression, evaluate the expression. Use if statements, switch statements, and switch expressions as needed within your applications. Use while, do while, and for statements as needed within your applications. Yep. Compare the if-else and switch statements. Compare the if-else statement and a conditional operator. Describe the differences between while, do while, and for loops. Explain how the break and continue statements work when used within a loop. Describe the use of breakpoints, the locals window, and stepping through code as they apply to debugging errors within loops. We've kind of looked at some of the debugging stuff. Debugging loops is pretty much the same. It's just going to loop through it each time, and you can check the values as it loops through, but we'll take a look at it. Describe block scope in the context of the control structures. So when we use these control structures, use relational operators. The operators are the double equal sign, the not equal, the greater than, less than, greater than or equal to, and less than or equal to. The double equal signs just check equality. If you use a single equal sign, it's going to assign a value, and that's not what we're trying to do. We're trying to check equality. The exclamation point and the equal sign is unequal or not equal to each other. And then of course greater than, less than, greater than, equal to, or less than equal to are pretty self-explanatory. So examples that use relational operators. Here we're checking the first name and see that it equals Frank. That's equal to a string literal. The string literal is Frank being in the quotation marks, so we know that's a string literal. Text_years.text, and of course that text_years.text is getting the value from where? Text box in the Windows forms that we've been working with. As you can see, it has the key, the naming convention txt, so we know it's a text box. That .text means it's getting that value of the text out of there. Here they're checking to see if it's an empty string with the blank quotation marks. Message, checking to see if it's equal to a null value. Discount percent is equal to 2.3. That's equal to a numeric literal. Because it's just a 2.3 and no quotation marks around it, we know it's a numeric literal. Is valid equals false. That's checking to see if the variable is valid is equal to the value of false. You'll see a lot of this is valid stuff on validation, checking to see if it's actually passing validation. If it does, you set it to true instead. Checking one variable against another variable. They're checking this variable called code against product code and see if they're equal. Here they're checking last name does not equal Jones with a string literal. So if it doesn't equal Jones, it's going to pass validation because it doesn't equal Jones. Years is greater than 0. I is less than months. Subtotal is greater than or equal to 500. And quantity is less than or equal to the reorder point. So it's checking a variable against a variable against a literal, and then years against a numeric literal, less than two variables. Logical operators. So logical operators, you have the double ampersand sign, that's a conditional and, so it checks to see if both values are true. So it checks the first value on the left hand side of the operator and the value on the right hand side of the operator. They both have to be true in order for it to be true. The double pipe sign here is the conditional OR. That conditional OR checks one value or the other. If either one of them returns true, then the value is true. If the first one returns true, it doesn't even check the second one because it has what it needs is one true value out of the two. They have the single ampersand sign for an AND. It returns a true value if both expressions are true. Always evaluates both expressions. So it's like the double ampersand up top. Most of the time you see it as this double ampersand. You don't see it as a single as much. Same with the single pipe. It stands for OR. Returns a true value if either expression is true. Always evaluates both expressions. This one evaluates both expressions. The double pipe up top only evaluates one. If the first one's true, it doesn't need to evaluate the second one. If the first one's false, then it will evaluate the second one to see if it's true or not. And then of course the the exclamation point down at the bottom, that means not. It reverses the value of the expression. So examples of some logical operators. You have subtotal greater than or equal to 250 and subtotal is less than 500. So what that does is it checks the value of the subtotal variable that you created, and either you declare the value of it or it picks it up through the user or whatever else gets entered. Checks to see if it's greater than or equal to 250. If it's not, then it's going to be a false statement because both statements have to be true. If it's greater than 250 and the subtotal is less than 500, if it falls in that range, then it's going to be true and it'll keep dropping down to the next line of code and run it for you. Time in service less than or equal to 4, or time in service is greater than or equal to 12. So what it does is check the first value, time in service, see if it's less than or equal to 4. If it is, it returns true. It doesn't even check the second part of the statement here, and it'll drop down and start running the code. If it checks the first part of the statement, time in service less than or equal to 4, and that's false, then it checks the second part of the statement, time in service, and see if it's greater than or equal to 12. If it is, then it goes and counts it as true, and it'll drop through. So the difference is the ampersand up top, this first line up here, it checks both values. Top one, it checks both values, the left side and the right side. The second one being the OR statement, it will only check the first one if need be, and if it doesn't pass the first one, it will check the second one. So it checks one or the other, the top one checks them both. Then you have the is valid equals true, and the counter plus plus is less than years. So it's just saying that both of these have to be true. And same with is valid equals true, it checks both of them to see if they're true. That one or that one is true. The next line down is date is greater than start date and date is less than expiration date, or is valid is true. So it's kind of doing three checks here. It's checking first to see if the date is greater than the start date and the date is greater than the expiration date. And then it checks to see if or is valid equals true. So any part of this can be true, and it will go ahead and run your code on the next line. And when we get down to the if else statements and that, you'll kind of see what I'm talking about when I say runs the next line. This one here is checking to see if this year's date is greater than last year's date, or employee type is equal to a part-time employee, and the start year is greater than the current year. So this one's doing a couple checks too. To do the beginning one, you put it in parentheses so it does the OR statement first, and then you do the AND statement following to check on the AND. I think there's a couple labs though you can set it up and run it like that to do a couple different checks at one time. And this one here at the bottom is just saying the counter greater plus plus greater than or equal to the years, and the exclamation point is saying not. So you got to consider saying is the counter plus plus not greater than or equal to years, and that's what the little exclamation point in the front saying is It just checks to see if it's not greater than years than that. So it can be a little confusing with the exclamation point in front, but just always think of it as the opposite of what's in here, and it's just saying not. So it makes it a little bit easier to understand that way. So the syntax of the if-else statement, it starts out by saying if, and then it has a conditional statement here inside the parentheses. So you have the if there, and then you have your conditional statement inside the parentheses, and it's like it says here, Boolean expression. So it's looking to see if it's true or false is what it's checking. So you're going to have some kind of condition. Say subtotal is greater than or equal to 250 and subtotal is greater than 500. So it's saying, is that true or false? If it's true, it drops into your statement here. And your statement is just some code that you run, and it'll show some examples down a little bit lower down here in the slide. Then you can do else if statements and do another check for a Boolean expression. So you can do like the line here, subtotal greater than or equal to 50 and subtotal is less than 500. If that's false, you can drop into this else if statement and run another Boolean check, and then you could do something like time in service less than 4 or time in service greater than or equal to 12. And if it's true, then again it'll drop into the statement here just like it does above if it's true. And if neither one of these statements are true, then you can use this else here at the very end to throw one last statement to kind of catch a default on everything that doesn't get caught by the first two Boolean expressions. So you're saying if this is true, run my statement. If this is false, else if, run this. Is this true or false? If it's true, run my statement. If it's false, do the else and run that final statement down there. I don't know if they give any good examples, but I'll do some code examples. Here's some if-else stuff here, but I'll do some code examples here in a little bit and kind of show you. If statements without else, if, or else clauses, and you just do a single check if, and you're saying is subtotal greater than or equal to 100. If it is, go ahead and drop in here. If not, run the next block of code. I don't like doing it like this. I like having the little squiggly brackets around everything so you can kind of tell what all goes with what. You can see here there's no squiggly brackets behind it, but it just runs this next line of code. The squiggly brackets hold some of the statements inside of it and run what's inside that squiggly brackets. If you have multiple lines of code like this here showing a block statement, it's got 2 lines of code with it. If you have more than 1 line of code, you need to put the squigglies around it so it runs both lines of code. If not, it'll just run the first line right underneath it. So I prefer having the squigglies around. Anytime I have an if statement, I always put squigglies behind my conditional statement there, like it's showing down here. I don't know. To me, it looks cleaner. You can kind of follow what's going on a little bit easier than the single one. But it does work like that, and you're more than welcome to do it that way if you feel comfortable doing it that way. An if statement with an else clause. And again, they're saying if subtotal is greater than or equal to 100, add this discount percentage at 0.2, and the M, of course, is for what? What? The M is for the decimal. It's showing that it's a decimal value. And then you think it'd be D or something to make it a little easier to understand than an M. But so then here are the statements saying if subtotal is greater than 100, greater than or equal to 100, and if that's true, add this discount percentage of 2%, else the discount percentage is 1%. And I know we do some of these in our labs to where you figure out, based on a certain condition, what kind of percent to add to it or remove from it. an if statement with else, if, and else clauses. And this one here is just saying if subtotal is greater than 100 and subtotal is less than 200. If that condition here is true, if this condition is true, drop down in this block of code or this line of code and give a 2% discount percentage. If it's false, it goes down to this else if statement. It does another conditional check saying subtotal is greater than or equal to 100 and subtotal is less than 300. If that's true, drop down here and run this line of code, which is a 3% discount. If that's not true, do one more check, this else if, see if the subtotal is greater than 300. If it is greater than 300, give them a 4% discount. If none of these are true, then drop down here and catch it with this else statement and just give a 1% discount. So what you're doing here is you're checking three conditionals, seeing if the number is between 100 and 200. Second one checks to see if it's between 200 and 300. This last conditional statement sees if the subtotal is over 300. And if it doesn't fit in any of those categories, catch it with this final else statement and just give it a 1% discount. So that's how you start figuring out some of the conditional stuff on here. You do checks to see where it falls into and then run the code based on it. In this example here, you can see there's no squiggly brackets after the parentheses. That's because it's just running one line of code afterwards, so it doesn't necessarily need those squiggly brackets. But to me, it just looks cleaner. A lot of times with those squiggly brackets, it's easier to kind of follow what's going on. So here's a nested if statement. So you can have an if-else statement inside an if kind of else statement. So they're saying here, if customer type is equal to R, and if it is, drop down here, then do another check and say if subtotal is greater than or equal to 100, give them that discount percent of 2%. Else, give them a discount percent of 1. And whatever it decides to run down here, it drops back out. So it comes in here, hits this next if statement. It'll do its check. It'll apply whatever it needs to, whether it's true or false, and then it drops back down. So if this if statement originally up here is false, it won't even drop into this code. It will drop straight down into this else statement and just give them a 4% discount. So with these if statements, that conditional operator bases on what's going to happen. So if it's true, it drops down and runs the next lines of code. In this case here, if it's true, it runs this next if statement. If this if statement is true, it drops down and runs this next line of code. If it's false, it hits the else statement and will run this line of code after the else. And then this if statement in general up top, the main one, if it's false, it won't even drop into this code here in the middle. It just drops right down to this else here and does this discount percent. So that's how a nested if statement works. You can have multiple ones. You can have an if, an if, an if, an if, an if you need be. I wouldn't get too crazy with it because it can get confusing on trying to run through it and drop through the right part of code. But you may need it for 2 or 3 different nested if statements, maybe at times. So it's good to get familiar with this. In your coding life, you will end up needing these at times. So the syntax of a switch statement. A switch statement just checks on a variable to see if the expression, where it matches your expression, and then it goes down through the cases and it will run a statement and break, checks the next case to see if it matches. It runs a statement and breaks. And these breaks, what the break does here is it makes it drop out of the code. So if you run through, you hit a case that matches and it runs the statement, it doesn't need to keep running through the rest of your code. It will break at this breakpoint and jump out of the switch statement and just keep running whatever code comes up next. So, example I think is coming up here. So here they're doing a switch statement with a default label. So what they're doing here is they're saying, check the customer type. If the customer type case is R, run this discount percent at 1%. And if the customer type is R, run this discount and then break. Jump out of this code. Don't even check the other case. Don't check the default. Just keep running the code. So then if the customer type is not R, checks this case, it's not R, it goes down to the next case and says, is this a case C? It's a customer type C. If it is, go ahead and give them a discount percent of 2%. And the 2%, if it is that, break here and jump out of the code. Don't go check the default or any more of the cases that you have listed. So, and then if it doesn't have a case of an R or a case of a C, it'll hit this default, and that kind of is like the else. It picks anything up that's not caught by our first two cases. And so it'll hit this default, and the default will give it no percentage. They get no discount. And then again, it breaks here and jumps out of the code, and then it'll start running the code that goes down below it. Switch statements you see occasionally. More often than not, you're going to use if statements or if else statements. You do occasionally see some switch statements. Switch statement that falls through the first case label, and they're kind of showing here. Customer type is R. There's a good chance there may not be a customer type of R, so it just drops right down into case C and checks that. And then it'll check for a case T. If it finds a case C, it applies a discount and breaks out of the code and goes down to the next line. If it finds a case T, it gives a discount percent of 4%, and then it breaks out of the switch statement and drops down to the next line and starts running the next block of code. Switch statements, once you set up a couple of them, they're pretty easy to understand and figure out what's going on with them. So I'll do some examples either later today or tomorrow on some of these else ifs, switch statements and stuff like that. So the syntax of a switch expression, which I have never used much in my coding life, I have always used the switch statement and not the switch expression. It's more of a shorthand on it. You do a match expression, then you switch it, and then you get your constant expression, and then expression, constant expression, expression. So you can see it's a little bit of a shorthand, so it's saying the discount percent is equal to customer type. Switch it. So if R is 1%, go ahead and switch. C, 2% switch, and then your default here. Since there is no customer type, it just gives it a 0% discount. So you see it's a little bit more shorthand, but this can be a little bit confusing, especially if you're not comfortable with switch statements or not familiar yet with switch statements. The switch expression can be a little confusing. It's just the shorthand kind of version of a switch expression. More often than not, in my coding career, I've always seen, like I said, switch statements and not necessarily switch expressions. Switch expression with two cases that return the same result. So they're saying, and you can see here, it doesn't have a break, so it's going to run through all the code as I'm thinking about it now, talking about it. There is no break, so it's going to run through and check them all. So switch expression with two cases that return the same result. It's checking the discount percent with the customer type. It does the switch. So if it's R, it gives a 2% discount. If it's C, it gives a 2% discount. If it's T, it gives a 4% discount. And then you can see it get to the end of your squiggly bracket. Got the semicolon, so that means it's the end of the line. That's the end of that expression, and it drops out of it. A switch expression with expressions that perform a calculation. So here again, it does the discount amount equal to the customer type, does the switch, and then it's saying the R, you take the subtotal, whatever that value is. It doesn't show it being declared anywhere in this little example, but they take the subtotal value and multiply it by 2%, so it's already figuring out your discount for you here instead of having to go down later on in your code and figure it out. Same here, if it's a C, it picks up the subtotal, multiplies it by 0.2, and if the customer type is a T, it figures out the subtotal, multiplies it by 4%. And again, if there's no RC or T for customer type, it defaults it, gives it a 0% discount, and then it goes down, runs through the code. Like I said, this can get a little bit confusing. I prefer the switch statements myself. Switch expression with relational operators. This only applies for C# and later. So they're taking the discount amount, applying the subtotal to it, doing the switch. Then they check and see if it's greater than or equal to 50. And again, that M is for what? Decimal. And is less than or equal to 200. Apply the subtotal, multiply it by times 2%. If it's greater than 200, take that subtotal and multiply it by 4%. And you can see some of this gets a little bit confusing. That's kind of why I like the switch statement. It's pretty straightforward, pretty understandable. The syntax for a conditional expression, the way they have this laid out, this Boolean expression, this is like your if statement here. It's saying if, and you run this Boolean expression, this is your conditional statement. The question mark is saying if it's true, do this part of the code. If it's false, do this part of the code. This here is called a ternary operator. You'll see this more and more as your coding goes on. It's a big time saver as far as coding goes. You don't have to type if, put the statement in, and then your brackets and stuff like that. This is just straight up saying, like down here, if the subtotal is greater than or equal to 100, if it's true, give it a 1% discount. If it's false, give it a 0.05% discount. So it returns 0.1 or 0.5 depending on what the subtotal is. So that's called a tertiary or ternary operator. Ternary operator. That's just a shorthand for an if statement there. So if this condition is true, run this true expression, semicolon. After the semicolon, it runs the false expression after the semicolon. It's a nice little time saver. You can run it however you want. If you want to do the if-else statements like that, you're more than welcome to. If you want to use the ternary operator, you're more than welcome to. You'll see the ternary more and more as you start doing your coding life out in the real world. You won't see them as much in here. How to use a conditional operator to set the value of a variable. So this here is doing another ternary operator kind of a thing here. They're declaring a data type of decimal. They're given a variable name called discount percent, and it's camel case. Again, when you do your variables, they should be camel cased. I noticed going through the Chapter 2 lab for naming conventions, some people had problems with the camel case part of it. Camel case, the first letter of the first word is always lowercase, and then any follow-on word after that, the first letter is uppercase. So they're taking a decimal data type, giving it the variable name of discount percent. They're assigning it the value, and the value is going to be decided by this ternary operator, subtotal greater than or equal to 100. If it's true, assign the variable discount percent the value of a 1%. If it's false, assign, and of course we're assigning it because of this equal sign here, you assign the discount percent the value of 0.5 if it's false. So just remember the question mark here is true, the colon is false. If it's true, do what's right after the question mark. If it's false, do right after what's after the colon. A statement that uses parentheses to identify the Boolean expression. And this is kind of like the if statement here, where they actually put it inside a parenthesis. So they're pretty much doing the same thing. They're doing a data type of a decimal. The variable name is discount percent. Again, it's camel cased. And they're assigning it the value and doing a check to see if subtotal is greater than 100. If it is, if it's true, apply that 1% discount. If it's false, false is the colon, apply the 5% or the 5% discount, or 5% discount. An if statement that performs the same task, and here it is again. Like I said, you can use the if else statement. This is the ternary way to do it. It's shorthand. This is the if statement doing the exact same thing. You can see the code is just a little bit longer doing that way, but you can read it a little bit more clean because you can see the if and the else instead of having to try and figure out what the question mark and the colon are.
Cleanest way to do it.
I like the if else statement. Just it's easier to read through it, especially if you're new to reading code. It makes it a little bit easier to read. As you get more familiar with coding and get more comfortable with it, I guarantee you'll switch to the ternary operator just to save you some typing time in that.
Will that auto, whenever we type it, will it auto?
More than likely IntelliSense will try and pick it up for you and code it out. Don't let it do it though. Make sure you, if it does,
make sure it's right.
make sure you understand what it's doing.
Right.
And I'll keep going back to this example, and you'll probably get tired of me hearing me say it, but I had the student that let IntelliSense code everything out for him. He had no clue on what most of it was doing because he was just letting IntelliSense do it. If it came to an error, he couldn't tell why because he had no clue what the code was actually trying to do.
It's saying it's right, but it's really not.
Well, he would get errors, and because he would let IntelliSense do it and not have a clue on what the code was actually trying to do, he had no idea what was going on. So at least if you have an idea what the code's trying to do, you can kind of pick up your errors and fix them going through the code like that.
One of the oldest things I've heard about programming is that the computer is only as smart as the person using it.
That's exactly true. And one of my favorite jokes in coding is an ID 10T error. Have anybody heard of an ID 10T error? I think
Yeah,
I told
get it every day.
Yeah, I told the other first semester students. So an ID 10T error, you get an ID 10T error. You put that all together, ID 10T, ID 10T error. So it's a old programming joke. So you get the ID 10T error as idiot. So.
Are we gonna have root tests on errors at all?
Yes, we will do some debugging and stuff like that. I guarantee you, the more we go into these labs and they get more complex, you will be using that debugger quite a bit to figure out why your values aren't what you expect them to, why you're getting null values, stuff like that. Yeah, Tim.
What was I gonna say? Oh yeah, when I was working on the lab yesterday, so you can install these and stuff. Whenever I was having the name of the object,
To get back at it, this if statement here, they're declaring a data type of a decimal. They're giving the variable name discount percent. You can see it's camel cased again, just like it is up on the lines above. Here they're doing an if subtotal is greater than 100. Here's your if statement here, if subtotal is greater than 100. Here they put it in parentheses, if subtotal is greater than or equal to 100. If it is, drop down to this line and do it. So if it's true, do this line. If it's true, do this. If it's true, do that. Else, if it's false, give the discount 0.5. If it's false, give the discount 0.5. If it's false, give the discount 0.5. So you can see the ternary operator, ternary statement compared to an if-else statement. Whatever you're more comfortable with, whatever you understand easier, you can use either one. Here's an enhanced invoice total form. This is from the book. Like I said, if you decide you want to work through the book and do all their examples, you make a nice little application. This is how they're doing it. This is how they're coding it out. So they're just doing a button click. You can see it's button calculate. They're doing a click. You can tell it's a button because they do the naming convention BTN, like I've been trying to point out the last couple days. Use a data type string, get the customer type text, a decimal for the subtotal. They convert that subtotal text into a decimal by this convert to decimal. We've been doing some of that already. And that's another thing I've noticed is when you are declaring your variables and converting them, you want to try and convert them to the same thing. So like if we have an int called number, and then we go get the text out of the text box or whatever, when we convert that, we want to convert it to, we want to convert, it's an int here, we want to convert it to an int over here, and then our text stuff over here. If we're using a decimal called number, when we convert it, I see a lot of people still converting it to an int. It's a decimal, we want to convert it to a decimal. And then our text stuff over here. If we use a double, and I see this a lot too, if we're converting a double, if we have a double for our value, when we convert this, I see a lot of people converting it to an int again. And it's not an int, it's a double. So we want to convert it to the same data type if possible. If not, the int will work because when it does some of the casting that we talked about Monday, it will cast it to an int because the int is a smaller data type or a different data type that can still be used, but then you lose the decimal. So if you're converting it into an int and it happens to have a decimal, you're going to lose the decimal. So when you convert it over here, you want to try and convert it to the exact same thing that your variable is set to. So being a double and a number, we want to convert this to a double. We don't want to convert it to an int. We don't want to convert it to a string. We want to try and convert our data type here with our convert to the same kind of data type. So if you have a double for your variable data type, you want to convert it to a double. You don't want to convert it to a string. You don't want to convert it to an int. You want to try and convert it to the same kind of data type. And you can see here in this example, they have a data type of decimal for subtotal. Well, they get this text subtotal text and they convert it to a decimal. They don't convert it to an int. They don't convert it to a double. They convert it to a decimal. And then as you go down, they declare another data type decimal. The variable name is discount percent. They're assigning the value of that discount percent to no percent, so 0.0%. So then they do an if, check the customer type. We get the customer type up here with whatever the user types in. The customer type is an R. If it's an R, they do a nested if statement here, and we saw that nested if a couple slides back. So they do a nested if, the subtotal is less than 100, give that discount percent of 0. Else if the subtotal is greater than or equal to 100, and again the double ampersand sign means and, so it checks the left side and the right side. Both of these have to be true for the statement to be true. And subtotal is less than 250, give them a 1% discount. If this if statement isn't true here, then it drops down to this next else if statement. Else if the subtotal is greater than or equal to 250, give them a 0.25% discount. So once it runs through these if statements, it comes back to the main one here and checks to see if the customer type is C. If the customer type is C, then it drops down in here and runs this little if else statement. And if it's not R or C, this final else statement catches anything else and gives them a 4% discount. So pretty straightforward. What they're doing is checking the customer type. If the customer type is R, check on a couple of different things to see what kind of discount they get for being a customer type of R. Else if, check to see if the customer type is C. If they are a customer type C, run through these little bit of code here to give them a discount based on them being a customer type of C. If they are not R or C, just give them a 4% discount. So then it does a couple other things. It gets the subtotal, applies the discount percent. For invoice total, it gets the subtotal minus the discount amount, and do a couple other things. Here they're giving it a percent, 1%. Here they're calling it currency, setting it to currency there. And then they set the focus on that text customer type text box that is right here. So you can see customer type is R. They do the discount percentage and all that stuff there. Almost like what we did with the console app where they ordered the t-shirts. That's kind of what they're doing here, something like that. Just a little more involved though. The syntax of a while statement. A while statement, you say while, and then you give it the Boolean expression. So you check on something, and if it's true, go ahead and drop down here while it's true. If it's not, don't even do it, just keep going. So here's a while loop that's adding a sum, adds the numbers 1 through 4. So here they're a data type of int and calling the variable name an I. So it's very basic, just an I for the variable name. They're giving it the value of 1, and then they create a variable type. And what kind of variable type is this? What kind of data type does this sum have? Anybody?
Should be int.
It should be an int because it's all declared on the same line. If they're declared on the same line, the data type is going to be the same for everything declared on that line. So the data type for sum is an int. Since it's declared on the same line, they're assigning it the value of 0. So now they're saying while I, which is 1, is less than 5, come in here, take the sum, which is 0, and add the value of 1 to it, and then increase the number of your I here. So if we look at it this way, we'll say while I, which is 1, so while 1 is less than 5, take sum, which is 0, and add 1 to it. So our sum would go from 0 to 1, and then our counter up here, which started at 1, will now jump to 2, and so 2 is less than 5. Yes, so let's go ahead and run this again. So then we take our sum of 1, we'll add 1 to it and make it 2. We increment our I, which then makes this 3. 3 is less than 5, so keep running it. So it keeps running it until this number becomes a 5. Once it becomes a 5, it's no longer less than 5, so it stops running through our loop, and then it'll drop out and continue on running code below it. A while loop that calculates a future value. This is a little bit more. So it's saying they're declaring a data type of an int for the variable name I, assigning it the value of 1. While I, which we see here, we set it the value of it to 1. So while 1 is less than or equal to months, and it doesn't actually show us what the months are, so we don't actually know, but considering most months it's 12 for the months, this would probably loop through 12 times. Each time it'd get the future value. Whatever the value of that future value is, they'd take it, add it to the monthly payment, and then they would multiply it by 1 in the monthly interest rate, and then they would increment your counter here, so that counter, your I, would go from 1 to 2. And it'd keep looping through it for the number of months. So if it was 12, it'd loop through till this was 12, which would equal or less than the months, and then it would finally hit it and drop out and keep running with your code. The syntax of a do while statement, it's kind of the same thing. You say do this loop, whatever the statement is in here, keep doing that while this Boolean expression is true. So you could do a do keep adding numbers, and then I think, was it last semester we had one that said that you keep putting grades in until the number equaled 999 or something like that. So like you can see here, this do while loop that calculates a future value. You have the int, which is the data type. Our I is the variable name that we give it, and we assign it the value of 1. So our I is going to equal 1. Do this, which is that future value equals, increment the I, and keep doing it while I is less than or equal to months. So we'd do the code first, increment it, and then drop down here, and then it'd keep running until we got to 12, if that's how many months we want to use, because that's usually what a year is 12 months. So it runs the code, it increments it, and then it'll update it as it runs through, since the while statement is at the end there. The syntax for the for statement, you'll probably use the for loop in your coding career more than anything.
Gotta love for loop.
Yeah. So what they're saying is for, and you usually set it up by initialization expression, and initialization expression.
You almost got it, buddy.
Yeah, I'll spit it out sooner or later.
By the end of the semester, you'll have it.
Yeah, hopefully I don't have to bring it up again like that. I'll just say int I equals 0 instead. How's that? Or int j equals 0 or 1. So the initialization expression is just declaring a variable like we did in these loops up here, where it's saying this int I equals 1, int I equals 1. And here usually you'll start with int I equals 0, and then your Boolean expression is usually I is less than whatever number you want that loop to run. And then you have an increment expression, and you increment your counter at the end of the statement. So what it's saying here is string numbers is null. For, you declare your integer I, give it the value of 0. We're initialization expression here, so we're initializing our variable and everything here. We do our Boolean expression, so as long as I is less than 5, keep running through this loop. Every time it runs through the loop, increment our count. When that count, which is our I, starts at 0, check 0 is less than 5, it is, run through it. Runs through it, it increments it one time, so our I will go to 1, 2, 3, 4. Once it hits 5, it stops. So then it takes numbers, and we can see our numbers is null. It adds the I plus a blank string. So it's going to print 0 through 4, because we're not going to hit 5 because it would be equal to it, and we're saying less than. So that would technically print out a string of numbers 0 through 4. With a block of statements, they're doing the same thing. It's just saying for, well, this int of I is less than 5, run through it, increment it every time it goes through, take the numbers, add 1 to that number, and then take that space and add that space each time. So then you're taking a number in a space, number in a space, number in a space. So you'll have 0 through 4 in a string. And I can show you some demos of that either later today or tomorrow, depending on how we want to proceed with labs today. A for loop that adds the numbers 8, 6, 4, and 2. So they're doing an int, declaring an int, the sum is 0, and then they're declaring, here's our initialization expression here, as they're initializing the value or the variable j, giving it the data type of an int. And 99.9% in these for loops, it's always going to be an int that you're running through. You don't want to mess with decimals or anything like that as you go through. They're given the value of j, the value of 8. They're saying j, 8 is greater than 0. Go ahead and go through here. But as you go through, we're not increasing the number. We're going to take 2 off our number. So our number starts at 8. We're going to take 2 off of that, and it'll be 6. So the first number it's going to print out is 8 because it runs through first, then it decrements it. Once it decrements it, it's at 6. Our sum of j will then be 6. Then it runs through again, it decrements it another 2 off that 6, it drops it to a 4, so it'll print out our 4. It'll go back through this loop one last time and say 2 less than 0, or 2 greater than 0, yes it is. So go ahead and print it out, decrement it to 0. Is 0 greater than 0? No, it's not, so then we stop printing out our numbers. So we'd have our numbers printed out at 8, 6, 4, and 2, and that's how you decrement
Mr. G.
a for loop. Yep.
Out of curiosity, like I know we've had assignments in the past where it's been like, hey, print all the even numbers, and that's where that would be useful. What would be a real world solution where you would want something like that?
To subtract, maybe like an inventory program if it's running through and saying keep checking to see what's left in it
Okay,
and
I
stuff
got you.
like that. Honestly, in my career, I haven't had to decrement too many for loops. Most of the time you're going through, yeah, checking a positive number and going up through it to run it through and get multiple values out of something. A lot of times, like you'll take a list and run through a list and keep checking the list and seeing what values are in a list that gets returned from a database and stuff like that.
Okay, I got you.
A for loop that calculates a future value. And again, we've looked at this future value a couple times. This is saying we're declaring the int here, initializing it here, giving it the data type of int, variable name of I, giving it the value of 1. So depending on where you want your count to start at, most of the time it's 0. You may need it started at 1. You may need it started at 2 or 3, but most of the time it's going to be like a 0 or a 1. We check our I, which is the value of 1 we just assigned it. If this 1 is less than or equal to the number of months that we declare, run through this future value, do the code in this future value, and then increase our I to a 2 since it starts at 1. And we're increasing our I. This is incrementing it. We kind of talked about that in beginning of chapter 4 lecture. So it increments that I, it adds 1 to it. So it makes our I a 2, and then it just keeps running through this every time until whatever we set our months at in our code, once it becomes equal to it, it stops after that. So usually months will 12. Once this high hits 12, it'll go through it. It increments to 13. The 13 is no longer less than or equal to our 12 months. So it'd stop running, drop out of the code, and start continue on with the rest of the code. A loop with a break statement. Again, like our switch statements we were talking about, this break statement just breaks the code, breaks it out of the code, and drops down to the next line. So like we're doing a while statement here, while I is less than or equal to months, and they don't tell us really what months, so usually we'll stick with 12 for a year. The I starts at 1. While I is less than or equal to months, run through here. Once it hits this message, future value is too large, which will be when it hits 13, then it will break out of here, drop out of the code, and then start running the next line of code. So anywhere you put a break, it breaks out of that block of code and drops down to the next one. You can use a return statement at times too to do the same thing. So if you're like looping through and you want it to stop at a certain point, you can use return. And when it hits that return, it will return back to the main part of the code. I would stick with breaks right now until you get a little more comfortable and familiar with using returns, but you can try and replace this break with a return occasionally and see what happens in your code. And that way you get more comfortable between the breaks and the returns in them. A loop with a continue statement, pretty much the same thing. You get a declare a variable with the data type of string, give it the name of numbers, assign it the value of null. And the reason they do null is you can't assign a string the value of 0. A string has to be letters for the most part. So this null is like a 0 or a nothing being in there, so null, if you're familiar with the word null. You could do a blank string in here if you wanted to, just to get kind of the same thing. So we're doing a for loop here because it starts with the keyword for. It has our parentheses on these loops. The for, your conditional statement, and your code goes inside the parentheses. Here they're declaring a data type of int. Variable name is I, assign it the value of 1. They're saying as long as 1 is less than 6, run through my code. And if it is, increment it by 1, so it'd be 2 and keep running through. Inside here they're saying numbers, which is null. Add I to it so that since it's null to start out with, there's no value in it. First time it runs through, it gets that value of I here. And of course that I is 1, so it starts out with 1. It'll do numbers, and then it's going to add this. Anybody remember what this escape sequence does with the end? New line, that's right. And it's called an escape sequence. So then it does that. It does a check. If I is less than 4, continue on. If it's not, then add that number's big. And so he'll keep going like that. So that's what a continue is. It's just telling it to continue on with the code compared to a break, which tells it to stop and jump out. You see the results of that loop. It's 1, 2, 3, 4. I is less than 4. Go ahead and print that big. 5, big again, since it's less than 6, and they're putting this big outside here. So a for loop with a breakpoint and an execution point. Again, with that debugging on the left-hand side. Get my Visual Studio up real quick. Because I'm just going through the slide and I'm not really giving any demos or anything yet at this point. If you read the chapter 5, it slows down for you as you read it instead of me just kind of breezing over the main points and key points and stuff like that. So like I've said multiple times, make sure you read your book. The book goes in a lot more depth and detail than what these slides do. When I try and do demos, I try and incorporate as much as I can out of the chapter to give you examples, but you'll still learn a lot more by reading the book than you will by just following along these slides or just kind of following along with my demos.
Can I throw some advice too?
Yep.
Mr. G's YouTube, both of them now since you're doing yours too. I was very successful last semester because I watched those videos after every class. Like they're like an hour long video per like subject. So you come in here, you listen to Mr. G talk about whatever we're working on. Go look at Mr. Goodmanstead's YouTube, and you can find the same topic, and he'll go into like other ways of learning it.
Yeah, he's been teaching this a lot longer than myself. Hopefully by the time I teach as long as he does, I'll be a pro at lectures and demos and everything like that. I'm still getting my feet wet at this point, so.
And there's links to Goodmanstead's YouTube like on our Discord too.
Yeah, so hopefully I'm explaining it well enough that you understand it. If not, definitely make sure you stop me, ask questions. That's why I always stop at certain points and say, any questions, comments, or concerns? If you feel like you're stuck or confused, ask then. If you don't want to ask in front of everybody, catch me on break. If you don't want to ask me then, I'm here in office hours from 12:30 to 3:30 every day. Like Nick has stopped by a time or two and asked for some help. I don't mind giving help. I'm not perfect with these lectures or anything by any means, so if you're confused on anything, I don't mind spending extra time outside of these lectures, outside of lab, helping you guys hopefully understand these concepts and all this stuff with it.
I mean, most of the second semester students shouldn't be confused anyway because conditionals and for they're old news.
Yeah, this is stuff you did in the JavaScript part of it, and so that might be why too it's kind of going faster, seems like it. I mean, a lot of you, I mean, there's a handful of new first semester students that this is all brand new to.
It's not even that hard for first semester students either, I know it.
Yeah, and you guys had practice with it already. So I'm just hitting the key points. That's why you have the book. Read the book. Understand what's going on with the book. You can read it, reread it. If you have to, you can watch these videos, rewatch the videos. Like I said, Mr. G's been recording his videos for years now, so his are pretty good. I was watching them myself before I actually started teaching the classes myself. When I came on, I shadowed him and I would watch his videos just to kind of get a feel for what was going on and what he was talking about, even though I was familiar with most of the concepts, having been doing development forever. I did Java, not necessarily C#, so there were little differences, but not a whole lot. But so like, let me open one of these up. And when you debug, again, you have your line numbers over here on the left-hand side. And then there's a little gray area all the way to the left. And as you move your mouse up and down in there, you can see a little gray dot. That's where your breakpoint is going to be. And the reason they call it a breakpoint is when you're debugging and run your code, when it gets to this breakpoint, it does what it says. It breaks your code. It stops it right there. And then you can walk through and get your values and see what's going on. So like say I put a breakpoint here. It highlights that line in red to say this is where it's going to break at as you go through it. This is where you run with the colored in triangle arrow part with the start. You run it there and that will start your debugger. So you can see now you get some extra panes of information down here. You'll get one down here that shows all your variables and such as you go through it. And I'll show you an example of that here in a second. So you see you get some extra panes down here. You get a little information over here. Here's my window. And it's telling me put some information in here. So I'll put number 22 in there. 33 in here, and I hit my calculate button. When I hit this button, it's going to jump in here and do my click event like we've been wiring them up here since we started doing these Windows forms. So I hit my calculate button, and you can see now my line turns yellow. There's an arrow inside my red breakpoint saying this is where we stopped at on this line. Here's what's going on. You can look down here in this bottom left pane, and you can see your variable names. So you can see I declared this data type of an int and gave the variable name number 1. You can see right down here is my number 1. It's got a value of 0 at this moment. That text number, the text box, is holding a value of 22 in it, and you can see there's quotation marks around it. Those quotation marks around it saying that it's a string. And you can look over here for the data types. You can see my number 1 here, up here is an int. My data type over here is an int. My text number 1.text box is 22 in parentheses. It's a string. You look over here on the type and it's showing a string. So there you have an idea of what's going on, what kind of data types you're using. Here it's telling me in this text number 1, and yesterday when some of you were running your applications and it would break on you, like my text number 1 down here, let me move this up and over so you can see a little bit better. This text number 1 down here, you can see that value over here is showing a text equals 22. And it broke because you need to call this text number.text down here, which actually has that value of 22 in it. So here, this text number 1 is saying it's holding this text value of 22, but when you actually call this text number 1.text, it's actually getting that value of 22 for you now. So when you try and run it without that .text on it, it was breaking because it didn't know what value to get. When we add that .text, it's saying, oh, okay, here it's holding this value 22 in text. Let's get that text and get that value 22 out of it. So then we continue running through. You'll see up here at the top, you have a red square. That stops the debugger. You have a 3/4 circle with an arrow on it. That will restart it all. To show the next statement, you don't use that very much, but the main one we want to use is the step into. It has the dot with the arrow above it pointing down, F11. So you want to use that when you debug. You click on this and it goes down to the next line, and you can see it populates our number 1 now. It has that value of 22 in it. It's an integer. Now it's starting to look at number 2. It initializes it, gets it ready. It's saying right now it's not picking up the value, so it's showing a 0 in it. You look down here at our text number 2, and it's saying it's holding this text of 33. When we actually get it and put it out here, this text number 2.text, it actually has that value 33 in it now, and it's a string. So then I can walk through it again. It changes my 33, it converts it to an integer. Now you can see all my values are integers. There's no strings, even though it's still holding this 33 up here as a string at the moment. But now it's putting all my values to integers since we converted them to integers. We start looking at our math part of it now. And so we should see this result variable show up. And here's our result variable on this line here. Since we haven't technically, we've hit this line, but we haven't stepped through it yet, it hasn't done our math calculations. So it sees this int result. It's holding this value as 0 at the moment until we step through and actually do the math conversion. So let's step through it with our down arrow and F11. Step down into it. And now you can see it did a result. It did our little math computation here. It gave us our answer of 55. It's showing it in the data type of an integer. That's what we expected because we called our result an integer. And both of our number 1 and number 2 were integers, so everything worked out. It talked properly to each other, so we got a result. Now we want to do our label here. We'll click down our label. And you can see our label result.text here is showing what it prints out the screen. That our string, it's a string because we see the quotation marks behind it and in front of it. It also says over here that data type is a string, and then it shows what's printed out to our screen. 22 plus 33 is 55. And like I said, once you start getting into more complex problems and parts of your application, you will be using this debugger quite a bit. So you can see the arrow move down to each line as it walks through. It's at the end here, and we run it again, and it should pop our screen up, show our display our results. You look up here, there's no more code to walk through, so it stops. We can rerun it, bring it back, and do the same thing. 55 plus 11. Hit this and it starts debugging again, and we just walk through it a second time. You can see the yellow arrow is whatever line you're on. You can hover over the numbers that you have here and it'll pick up the values there too. So you can see I'm hovering over number 1. It's showing my number 1 is a 55. My number 2 is 11. My result should be a 0 because it actually hasn't stepped over this line yet. It's sitting here. So when I step over it, now if I hover over result, it'll show 66. 55 plus 11 gives us a result of 66. And again, you can see it all down here in this box. Keep walking through, and we're almost to the end of our code. You can see the little squiggly bracket it's on. Now we hit the end of our code, and it pops our window back up. It shows us 55 plus 11 is 66. So that's how the debugger works. It does the same thing for the loops. It's just going to loop through each time. It'll increment it, and you'll see everything going on with it just like that. It all works the same. It just depends on where you put your breakpoint to have it fire when you're running through your code, so make sure you put it where you need it to. Here they're showing it right on that first line of the for loop, And that way you can check your variable values for your I, make sure it's declared properly, and then your increment here, it will show you how it increments. So it's pretty easy. How to set and clear breakpoints. To set a breakpoint, click in the margin indicator bar to the left of the statement. That was the gray area I kind of pointed out over here. To get rid of it, you just click on it again, and it will go away when you click on it. Stop it, and I'll show you. So there's my breakpoint. You click on it again, and the breakpoint's gone. You can run it without it stopping, breaking. So we'll press F9 to set a breakpoint at the cursor insertion point. Then a red dot will mark the breakpoint. To remove a breakpoint, use any of the techniques for setting a breakpoint. To remove all breakpoints at one, use the delete all breakpoints command in the debug menu. How to work in break mode. In break mode, a yellow arrowhead marks the current execution point, which points to the next statement that will be executed. To step through your code one statement at a time, press the F11 key or click the Step Into button, which is that dot with the arrow above it. And it's not going to be there yet because I got to run through all the code. There again is that step into. The step over here will jump over some of it. There's sometimes on these debuggers where it'll actually, it can take you into this like convert 32 int and debug through there. You don't usually have to mess with that because that's a system supplied object and method, so you shouldn't have to worry about errors coming out of that. It's going to be more than likely your own code that's causing errors and not the system code. And then you can step back out. So if I go down a couple, I can step back out of them and get me back up to the line. So as I said, get in more complex applications than that debugger will become one of your best friends. Continue normal processing until the breakpoint is reached. Press the F5 key. Here they're just showing this future value form from the book again. Like I said, if you want to code along with the book, go for it. They do some pretty nice applications. They explain them pretty well. They show you the code for most of them. Properties for setting the form. You have the form. You have the text, accept button, cancel button, start position, that kind of stuff. All the labels, all the text boxes. And you can see again the naming conventions. The text box is TXT. The button is BTN. The label should be LBL. And then they have some additional property settings, and like I said, that's where that styling goes. You can text the line, you can set your tab index. And here they, like I mentioned the other day, with the tab index, you want to usually set it so it moves from top to bottom, left to right. Just clean that way. Usually that's how a form goes when you fill out a form. Here's the code for that event handler for the future value application. I'm not going to go too much into it because knowing students how they are, none of you are probably doing this little application that the book's supplying. If you are and you decide you want help with it or anything, feel free to ask and I will help you with it. Here's application that calculates a factorial of a number. Change calculator. We did one of these in JavaScript, and you can see pretty much what you can do in JavaScript you can do over here in these Windows forms or on the console apps. Here's one where it's calculating income tax. And I don't think we do any of these actually in our labs, but as examples I can code them out if anybody wants to and demo them. So objectives, part one, applied, given a Boolean expression and the values for the variables in the expression, evaluate the expression. That's part of what's going on in your if statements there. Use if statements, and switch expressions as needed within your applications. Use while, do while, and for statements as needed within your applications. I know a couple of these chapter 5 labs you're going to do a do while loop. there's one, I think you enter grades or something, and you keep doing it until you hit a certain number and tell it to stop. And while you're doing these do-while loops, just as a bit of information, a lot of times in the do-while loops, you'll do them until a user enters a certain number. I think in our JavaScript class, some of them were like 999. So you enter 999, it'll stop that do-while loop. Let the user know what it takes to stop that loop. If not, they're not going to know how to stop it, so they're going to get stuck. They're not going to know how this program works. So if you let them know, enter 3 numbers, hit 999 to stop it, that way they know how to get out of that loop, how to end the program and get the data they need to get out of it. So just a hint that helps the user know how to get out of your code. Compare the if, else, and switch statements. We did that. Compare the if, else statement and conditional operator. Describe the differences between a while, do while, and for loops. Explain how the break and continue statements work when used in a loop. Describe the use of breakpoints, the locals window, and stepping through code as they apply to debugging errors within loops. And describe block scope in the context of control structures. Didn't necessarily do that, but the block scope is the parentheses that follow an if statement or a loop. Inside the squigglies is the block code that they're talking about. So when you see that and they mention this block scope, that's just your variables created inside those squigglies, and that's where they get used at, is inside those squigglies. They don't get used outside, so if you declare something in here, it stays in here. You can't use it outside of that, it won't find it. So they declare numbers up here. If you did it inside the squiggly brackets here, you wouldn't be able to use it outside this for loop. Since they declared it outside this for loop, you can actually use it outside the for loop if necessary. So inside the squigglies, it stays inside the squigglies. What happens in the squigglies stays in the squigglies, kind of thing, if anybody's been to Vegas. So that's kind of how the block scope works. You can use global variables if you need to. This is outside the block scope, so it can be used elsewhere. So that's what they mean by describe block scope in the context of control structures, is just what's inside the squigglies after your conditional statements and that. So that's pretty much chapter 5 in a nutshell. Like Ryan said, it did go by pretty quick, and it does seem like we are getting through some of these chapters pretty fast, but we'll have some lab days coming up in that now to give you some time to work through these. I can set up some demos. Time is 9:35.